So we have 0.003x plus 0.4 equals 2.05. All right, so we're going to get rid of the decimals. That's the first thing we want to do is I want to solve this without decimals. Whichever one has the most number of decimal places is what we're going to have to move them over every single time. So this one right here, we have 3 decimal places in order to make it a whole number. This one only has 1, and this one has 2. Since this one has 3 decimal places, we need to multiply everything by 1,000. All right? If it was 2 decimal places was the most, what would we multiply by? 100. And if it was 1 decimal place that was the most, what would we multiply by? 10. All right. So since it's 3, we're going to multiply the entire equation by 1,000. If you want to put parentheses and do 1,000 in the front, you can. Or sometimes I like to write 1,000 next to every single term to remind myself that I need to multiply everything by 1,000. Okay? So, yeah. Oh, I did. Well, see, thank you so much, though. All right. So I'm going to move it over 3 places here, and I get 3x. And then I'm going to move it 3 places here. So 1 would be here, and then 2 more places makes this 400. Okay. And on this one, I'm going to move it 3 places. That's 1, 2, and then a third one would add a 0, just 1 0 onto the end there. And now this becomes a fairly easy problem to solve. So we're going to subtract 400 from both sides. So 3x equals, what is that, 1650? And divide both sides by 3. So 15 would be 5, another 15. Did you guys get 550? Those of you that, nobody, everyone good? Okay. All right, good. Thanks for helping me out. So that's it for decimal. That's just a kind of a review. I know you guys have seen those before. All right. The astronomers found that 0.017 of the stars examined were red dwarfs. If 29,000 stars were examined, how many were not red dwarfs? So this is really similar to what we did yesterday when we had the Victorian and the not Victorian problem. Okay, so we're going to do ratio box. Okay, and over here we are comparing whether or not they are red dwarfs or not red dwarfs. So, red dwarfs, not red dwarfs, total. All right. So we have 0.017 that were red dwarfs. So that goes here. Normally that's where our fraction goes or our percent. All right. This time we're doing a decimal. Okay, the total is always 1. So we actually need to figure out the not red dwarfs. Anybody know how we would figure that out? Sam? Yes. Okay, 1 minus that decimal. So if 0.017 are red dwarfs, then anybody got that? What that actually is? 0.983. Okay, so we always get that by doing 1 minus. All right, if 29,000 stars were examined, so 29,000 is the total, 29,000 were examined, how many were not red dwarfs? So we need our variable here. And we're going to cross multiply. So we have this times this, and I'm going to use 0.983 times 29,000 equals 1x, which is just x. Okay, this is how many were not red dwarfs. Anybody have a calculator and figure that one out? Sydney, right? Okay.
2,507.
Cool. Okay, and always, always, always label your answer. So this would be, we're not red. How do you spell that? W. There we go. Okay. All right, this is important. A lot of people forgot this part. I do remember this being on a test. Not this week, but probably the next one. Okay. All right, find three consecutive even integers such that 3 times the sum of the first and the third is 84 less than 12 times the second. So you did these consecutive integer problems last year, but you want to remember whether you're doing consecutive integers or you're doing the evens or the odds, right? So if you're just doing normal integers, so you're looking for consecutive one right after the other, then we use n plus 1, n plus 2, right? That's if it's just consecutive integers. If we're doing even, anybody remember what that looks like? Leo? Good. Okay. And this is the same whether it's even or odd. So basically you're always 2 away, right? So from 1 to 3 is 2 away. So any evens or odds, you're going to use n plus 2, n plus 4. And so this would be the first number, the second number, and the third number. So I like to label them, and then I know which is which. Okay. All right, so find 3 consecutive even integers such that 3 times the sum of the first and the third. So we have 3 times the sum. When you're multiplying something times the sum, you need parentheses, all right? So 3 times the sum. And then the sum, we're adding. So sum means I'm adding 2 different things. So 3 times the sum of the first and the third integer. Well, the first integer is n, and I'm adding it to the third integer, which is n plus 4. Okay, and then I have is, that's my equal sign. Okay, again, 84 less than. That means you have to leave a space and then put a minus 84. So 84 less than 12 times the second. So 12, and we're going to multiply times the second integer, which is n plus 2. Okay. Now we're going to simplify. You could add these. I like to do this part first. N plus n. This is 2n plus 4. I'm just going to write it up above. Then I'm going to distribute the 3. So 3 times 2n is 6n. 3 times 4 is 12. Okay, on the right-hand side, I have 12 times n, so that's 12n. 12 times 2, so that's 24, minus 84. And you guys finish solving this and tell me what you get. All right, Nate, what'd you get? Okay, both Nates, good. You guys got 12? Both Nates agree? Thanks. No, it's okay. All right, so we get 12, and then that's the first integer, right? They're consecutive even integers. If you get an odd number, did you mess up? Yes. Okay, on this one. If you get a decimal, did you mess up? Yes. Okay. So it's 12 and then 14 and then 16. Don't forget to do this part where you find all the integers that it's looking for. It did say 3 consecutive integers, so 12, 14, and 16. Okay.